Hi, everybody. Welcome back to our Fungible Token series. It has been a really long time since our last video, and there's been a reason for that. We have been building a lot of code, and we're super excited to be able to share it with you today. So I made a comment during one of our previous tutorials. You shouldn't approve a canister that you don't trust, or that you only want to approve a certain amount. When I said that statement, it made me think about something, and it sort of stuck with me for the last number of months. And I've been working on a number of different pieces of code that all sort of work together that achieve what we're releasing today. What ICRC1 and ICRC2 and ICRC3 and ICRC4, what all these things produce are standards that you can put into your smart contract that can assure people that the code is going to do what it's going to do and nothing else. Except that the internet computer allows you to upgrade smart contracts. So if you don't know the code that's running on a smart contract that you're interacting with, the assets that you own on that canister aren't really yours. There's no telling if you'll lose the assets or not. Any rights you give to that canister can be used to potentially abuse you and steal resources from you. There's only a couple ways to ensure that this doesn't happen. The first is what's called a black hole. And a black hole means that you set the controller of a canister to some principle that no one knows, or a known canister that's called a black hole canister that it can't be upgraded. So it's black holed, but it has a few functions that you can trust. Cyclops uses this form of black hole that can actually check controllers, but it can't do anything else. And so you're limiting a black hole either limits the scope of what a canister can do to something hard coded, or it just is nothing. If you send tokens to a black hole, that's a private key no one knows, that it's just lost. Those tokens are lost unless somebody magically guesses the private key, which is almost impossible. The next best thing we have to a black hole is something I call a Dow horizon. It's a black hole, there's an event horizon where once you get into the event horizon, you can't escape. So a Dow horizon is where you submit your canister to a sufficiently decentralized DAO that gives you beyond reasonable expectations that your canister will not be violated, that your resources won't be stolen, that the code won't be updated unless there's a very, very, very good reason. So there's lots of canisters on the internet computer that are DAO horizoned, the entire NNS, all of those management canisters, the CK-BTC canister, the CK-ETH canister, the CK-ERC-20 canister, all of those are DAO horizoned to the NNS. So every once in a while, you'll see a proposal come across that'll say we want to upgrade the CK-BTC canister. It'll give you a WASM, and if you actually look at that proposal, you can pull down the WASM binary that gets installed. The NNS can upgrade that, and the NNS can actually upgrade any canister on the internet computer. What we wanted to do is build a service that has pretty good assurances that no one can ever steal your money, because what we're going to build is a subscription service canister. And what this allows you to do is to approve this canister to spend infinity amount of tokens out of your account over time. And you can be assured that this canister will not cheat and won't take more tokens than you have approved. So for instance, if I subscribe to Netflix, it's $7.99 per month, and I want to approve them to take money out of my account every month. Usually I use a credit card. Well, we don't have that functionality. I can approve Netflix on my token account for $7,000, and that will cover me for about 1,000 months. But if Netflix owns that canister, they could cheat. Their stakeholders could vote to raise the price, and without my approval, pull more than I had originally thought. But with a Dow Horizon canister or a black hole canister, that's not the case. So what we're going to do today is we're going to build a subscription service, and we are going to submit it to control by the NNS. Now, I would love a black hole canister, but we haven't finished this canister yet, and there's some important features that we want to take a look at. So the first thing, we're going to do a few things today. We're going to look at ICRC-79, which is a draft standard for subscriptions on the internet computer. It's a very basic subscription service that lets you do a few important things. We're then going to use a ICRC-79 library that has been written by Pan Industrial, and we're going to create an ICDevs NNS subscription canister. That subscription canister will be able to be trusted by anyone or any service to create a subscription against it. And that service will then execute that subscription every month or week or day or however you set it up. And then finally, we're going to add to our ICDevs website where we've added our ICDV mentor. We are now going to add a place for you to subscribe donations on a monthly basis to ICDevs. What we're going to do is what sounds like a very dangerous thing, which is we allow you to approve your donations for up to 30 years worth of donations. So if you say, I want to give 1 ICP a month to ICDevs as a donation, we're going to approve you for, I think it's 360 ICP. Now, if you only have 20 ICP in your account, we obviously can't take more than that, but we also can't change the canister. So it will only do that. It will only execute every month. And if you run out of ICP, you'll lose access to any benefits that we give for the subscription, but we can't take more than is in your account. So this allows you to approve a very high number of ICP without the fear of the smart contract cheating you. If all of that works, we're going to give control of this utility to the NNS. Now, this is a dangerous thing to do, and we've been talking on the forum a little bit about this, and Dfinity is not super sure they want to go this route. The worst case we have here is that we need to redeploy our canister and start over if Dfinity really doesn't, and the NNS votes to just say, we're never going to upgrade your canister. But because this is a very broad, useful utility, I think that it's a good candidate for a open, decentralized utility service for the internet computer that can be controlled by the NNS. And as we continue to build out and approve ICRC-79, because it's just a draft, we may have to change some things to align with what the final standard ends up being, as well as the Pan Industrial library hasn't implemented the whole standard. So there's things like exchange rates that aren't implemented. There's things like notifications that aren't implemented. But in the meantime, the subscription service theoretically works, and through our testing has worked. So let's jump into the code and start looking at it. All right. So the first thing we want to look at is this Pan Industrial library. I'll put the URL to the repo in the description. Inside this, there's an ICRC-79 markdown file, which will explain ICRC-79. The first thing I'm going to do, walk through this and give you an outline of what ICRC-79 does. So we're creating subscriptions here, and ICRC-79 is a standard that will let other services create subscriptions and be assured that they're going to get their money on time according to the smart contract. We allow for an interval here, so you can subscribe all the way down to an hourly basis. It's up to the implementation, sort of what they want their minimum to be. I think we set it up to maybe a daily subscription. There are subscription requests, which are going to create a subscription. So as we look through a subscription request, we're going to have a token canister. So a token canister is, for instance, ICP has a ledger. That's going to be your token canister. There's a token pointer, which is not implemented or used right now, which is an ICRC-80 thing, which we've seen a standard for, which is a multi-token canister. There's interface support for it, but not functional support for it. The service canister is the canister of your service. So if you are building a Netflix on the IC and you wanted to have your governance canister of your application, that's what you would put for your service canister so that you could interact with subscriptions. This service canister is going to be able to do things like pause the user subscription, cancel the user subscription, query the system for subscription data. It's also worth mentioning right now, this service is not private. So these are public subscriptions, which it would not be difficult to make it more private, but because the data is not encrypted on the node, it didn't make sense at this point to try to do private subscriptions. We have that interval that you can set amount per interval. Interval is a NAT, so that's the number of tokens per interval. So if one ICP would be 1 E8's worth, so 1 and 8 zeros. There is a base asset that you can set. This is not implemented, but the idea is that if you wanted to say, I want ICP and I want $10 worth, you would be able to set up the base rate asset to USD and use the exchange rate canister to go and figure out each month or each interval what the price of ICP is today and take a $10 worth of ICP. The end date of your subscription, which is optional, you can have no end, or you can set an end date for your subscription. Target account is the actual account that you want your money to go to. If you don't provide this, then it just goes to the service directly, to the root account of the service. Product ID is bespoke across different service providers, so it's not unique. Any service provider can use the whole range of natural numbers to produce different products. So if you want to have different products for different subscriptions, in the current implementation, we're only allowed to have one active subscription per product, per account. You can set when you want the first payment to be. So if you don't want the first payment to be immediately, you can set it to sometime in the future. You can also set a now payment. If you do set a first payment in the future, you can set a now payment. So say you always want your money to come in on the first. You can do that calculation to find the first of the month, set the first payment for the first of the month, but then also have a now payment amount which will be charged immediately. So you can prorate the first month and then it'll pick back up on the first of the month. You can provide a memo, a created at time for deduplication, and a sub account of the caller who's making the subscription. This will be used in ICRC2 to specify which account you want to approve out of. When you get back a response, you get back the transaction ID and the subscription ID. So that's the transaction ID on this subscription, ICRC-79 subscription canister out of the blockchain for this service. It has its own blockchain that you'll be able to track and see from Genesis what the subscriptions have been and what the status changes of those subscriptions have been. And also the subscription ID, which is in that. We have a number of errors. These asset classes and exchange rates results will be used in the future. They map to what is in the exchange rate canister. If you need to use ICRC-17 to block potential subscribers, say you have your own KYC server and you want to make sure that only United States citizens can subscribe, and you have a process for adding principals and accounts to that, then what you would need to do is set your first payment in the future, get notified or monitor new subscriptions and vet those people. And if they're not on that KYC, then you can block them or you can cancel their subscription before the first payment's processed. But you have to handle it on the client side. And then for fees, payouts to other services, that needs to be handled through some sort of proxy payment pathway. Broker is a future feature which will allow others to sign up users for your service, and you can offer them a percentage of the subscription by doing that. Some errors, standard account. As you pay money, a payment record is produced, and so you can go back and look at all of your past payments that you made through the subscription service. This data captures that. A pending payment query will tell you when to expect your next payment, so if you need to pull those for accounting reasons. There are also system notifications that can get produced. So when a customer is a subscription, when you get to a point where the allowance is insufficient for processing your item, when you run into a ledger error of some kind, or the service ends a subscription, or there's an exchange rate error, all of those get logged into your services inbox, and your service can query those later. Like I mentioned, there's exchange rate information you can put in here. We describe all the intervals, talk about the first payment. Then there's a subscribe method where you can pass in a vector of subscriptions that you want to create. You cancel the subscription. Confirm subscription is a canister-based function that can only be called by other canisters because you have to pass it, I think it's 5 million cycles for each request. And what it does is it will check the allowance to make sure that the user has an allowance for their next payment, but that their current balance is high enough for the allowance. Either the service or the user can pause a subscription for any reason. So if you don't want to cancel the subscription, if you're a service, you want to cancel the subscription, but the user's out of money in their account, you can pause it instead, and then you can restart it later if they end up with money in their account. There are query methods to get your subscriptions, your payments, and so on and so forth. Then there are a set of block schemas for the blockchains. These would be the ICRC3 for ledgers. There's a blockchain for this as well, and we define those. A little bit of metadata that is fairly irrelevant for what we're trying to do. We do transaction deduplication. So it's 10 million cycles per confirmation, and then because it checks both the allowance and the balance and makes sure that those are available for your next submission. So now I'm going to walk you through the utility contract so you can see at a high level what it is, which it's mostly a wrapper around the underlying library. Once we've seen the wrapper, I'll dive into the underlying library and show you sort of what's going on. So here is our subscription utility. So just like ICRC1 and ICRC2 and ICRC4 and all of those items that we did in our tutorial, the ICRC-79 uses the class plus pattern. It also uses a timer tool, which is a tool written by Pan Industrial to control. It simplifies the timer API a little bit in the sense that you can schedule a bunch of timers and they kind of run in parallel when it's time. So it keeps track of when the next timer is. So if you need a bunch of timers, instead of instantiating 1,000 timers and then having to keep track of all of them, and then when you upgrade, having to reconstitute all of them, it just keeps track of the most recent timer and has basically a database of future timers, and it will execute all those events in order. And then if you upgrade your canister, it'll also basically restart the timer process for you and process anything that was missed while you were away. And then it has ICRC3 as well. So we'll have the ICRC-79 migration state, the ICRC3 migration state for our blockchain, and the timer tool migration state. There is a block map, which is probably controversial at this particular point, but until we finalize this contract and are able to submit it, basically what ICDevs has done is put in a shim for blocking fee payments for now. Ideally, this would be just a network utility, and I think what may happen is eventually when we upgrade this, I don't think the NNS wants to be voting on blocking people, but another DAO may, if the feds show up at your door and say, this is a child trafficking subscription, you need to block this, we need to have some ability to be able to block that person from getting any fees. So we do have that in there. There's nothing added to it right now. It's just open. We then instantiate our ICRC-79. You may recognize this as the ICDevs ICDV token canister. So basically right now what happens is there's a public goods account for ICRC-79, and currently it's set at 1.5% of each subscription payment goes to fund public goods. Typical credit card fee, at least in the United States, is 30 cents plus 3%. This is just a straight 1.5%, and that gets processed each time. Now, depending on what token your subscription is in, what we eventually want to do is the ICP tokens will go directly into be minted into ICDV and given to ICDevs as ICDV tokens as well, so that we can use those to fund developers. So that's the plan. This is our initialization. The ICRC3 initialization happens as well. And one thing we should look at are these known tokens. This is another thing that ICDevs currently has access to in this contract, is to add new known tokens. We don't want to call ledgers that can be upgraded by any old body, because they could eventually block the upgrading of our canister. So currently, ICDV, this chain fusion tokens, water neuron, all the SNS tokens, all of those have been added, and so you can subscribe in any of those, create subscriptions in any of those tokens. And obviously, as new SNSs are added and new tokens and things like that, we'll have to go add those. That'd be another thing that would be nice to eventually hand over to a DAO. I know ICP Swap and a couple other DAOs do that already, where their DAOs approve their tokens. But we can go look at this known tokens. If we look in the ICRC-79 library, you can see that this is just a vector of principles, or it's a vector of tokens and then token info. And it creates a map inside the deal. So I don't like this very much because the total supplies are hard coded right now. I'd like that to eventually be fixed. Then we set up our timer tool. Here's our can send fee that's going to look at that block list. Really, this only applies to the sending of fees. So the donation amount that the public goods account, which is ICDevs, gets, that's what we're currently blocking right now. We're not actually blocking the subscriptions. What this does is it checks our fee detail to see if either the service, the account, the person that's subscribing, the target account, or the fee account, if any of those are blocked, it won't send the fee. Now here we instantiate our various classes. You should recognize some of this from the ICRC1. And then we get into our core functions. We have our subscribe function. And all we're doing is passing into these ICRC-79. So there's subscribe, cancel subscription, confirm subscription, pause subscription. Then our queries and metadata. For every item, we've added a _001 endpoint. We've done this so that if you want to develop against this API, you may want to use these 001s, especially if you're deploying a canister that is hard to upgrade. If the API for ICRC-79 does change, you don't want your other contract to stop working. So basically, the spirit of this commitment is that the 001 API won't change, and this could be a real pain in the butt later. If we can, we will try to take a call to that and upgrade it to whatever the next version of the API is. So we'll try to do that. If there is some just fundamental underlying change of the service, then we might have to go to a 1.0, which breaks everything. And so you need to fundamentally change some of that. But in most cases, you can assume defaults and things like that and make sure that past API stays in place. And then we get to the in. We have our ICRC3, get blocks, get archives, so on and so forth. Here you can get the token info. So this will give you the list of known tokens if you want to look those up. So that if your service wants to know what types of tokens you can use for subscriptions, and we'll see that later. ICDevs is set up to allow the addition of specific tokens at this particular time. And then we can also block a service. So we'll just have to, in the future, if we want to block payments, we'll have to upgrade the canister to do so. But at least here we're blocking the fees. So ICDevs is protected. It won't be paid any fees if somebody uses the subscription service for a nefarious purpose. The next step would be asking a DAO to approve the actual blocking of anyone using the subscription service. So in this instance, if the fee is blocked, then it just isn't paid. So let's now go into the ICRC-79 subcomponent that was written by Pan Industrial. We will take a look at the structure of it. It's very much like our other ICRC components that we've seen, looking at our state. So what's inside of the state that we hold? Well, we have a payment. So we're going to create a map of payments that maps an ID to a payment record. So we'll be able to get any payment by ID. We have a subscription here is a global subscription map, which is a map of a subscription ID to a subscription state. So those are the core places where the subscriptions, the payments are held. And then we have a couple indexes, right? So we have the user subscription index and the service subscription index. And what this allows you to do is the user subscription, give it a user. I can then go down by sub account into another map, and I can then go down into, let's look at it. So there's a user subscription, which is a principal to a sub account. Then we map from the sub account to a service subscription. Then we can look up by service. So if you have subscriptions, and if inside the service you subscribe to Netflix and to Disney Plus and to Apple, those would all be under your index, but separated out by different services, because those services would each have different principals. There's then a product subscription map, which keeps track of that service can have multiple products or a null product, and it keeps track of that versus a set of subscriptions. When you have an active subscription, you can't create another subscription for that same product. So you have to cancel it, and then you have to create a new one. So we want to keep track of old subscriptions that we have. Those will stay in the state. We don't have any archiving in here yet, so that's something that we'll have to keep in mind. Hopefully, we'll eventually get the new Motoko, and we can push that out, and this will all be held, and 480 gigabytes will be plenty for a long time. Hopefully not. Actually, having to do archiving would be a great problem to have. But that's that index. A service index is shorter. It's just a service to the service, then by product, then by subscription. We keep track of our token info. We keep track of asset info. This is not actually used yet because this will be for the exchange rate assets that are added later. We may only want you to be able to map to dollars or euros or Bitcoin or ETC, and not, if you say you want to pay in OGY, but worth 6 boom, then you become exposed to both of those, or one of those items crashing and burning, and then you can take everybody's OGY. And so we may want to really only peg and offer that exchange rate for very stable assets that are not going to crash and burn that we know of. Probably controversial to say that the US dollar is stable with this crew, but it is what it is. Notification map. Recent transaction is used for deduplication. If somebody's in there double clicking on your subscribe button, we don't want to create 2 subscriptions for them. So we keep track of that. Public goods account is in our state. Keep track of our next IDs. notification IDs, exchange rate canister, the basis points used for the fee for the public goods account, and then some just general stuff for batching. In our environment, we have the add ledger transaction, that ICRC-3 interact functionality. So this will call out to ICRC-3 to build a blockchain. We pass our timer tool into it as well. This can send fee blocks the fee. And there's advanced, which has the ICRC-85, which is the open value sharing. This ICRC-79 that Paint Industrial uses does have open value sharing. It's currently configured to send an XDR worth of cycles for every 100 subscription payments processed. So then the timer tool, I think, sends $1 worth of XDR every month, or up to $10 depending on how many events are scheduled. I think it's about 100,000 events or something. Every 100,000 events, up to $10, it adds $1 of cycles for open value sharing. So it does pay out some cycles. Obviously, it's a bit of a circular thing here because if the services want to keep getting their subscriptions, they are incentivized to make sure that the cycles get topped up. Similar with ICDevs as sort of a contributor of last resort. If there's a bunch of subscriptions and we're going to be getting a public goods account payments through those, we want to keep the thing up. So that's the way we'll sort of keep the cycles up and running. So that's probably a good place to stop with the types. The rest of them we'll see as we go through the library. It's a fairly robust library at a couple thousand lines. Good bit of it's just boilerplate, but we parse subscriptions here. When the requests come in, we have to process those. It's fairly straightforward. It does use an interesting pattern where what you pass in, and we'll see this when we look at how these are submitted. Items come in as variants. So the input here is I'll show this to you in the types. It's actually in the service definition. It's a vector of request items, and they're all variants. So basically it assumes that you could put one of these or none of these in. I don't think you can pass in an empty array, but I think you need token canister, interval, and amount per interval. But if you have those, that's all you need. Those are the only 3 variants in your vector that you need to provide to instantiate a subscription. The rest of them are optional and you can add them. So it cuts down a little bit on the boilerplate when you're having to create data on the client side. You don't have to name all of the variants. You only have to put in the ones that you want, which is, I think, a nicer pattern for Motoko. So this parses those out and then returns back a parsed item. This adds token info. It actually is going to call this get token info, which calls out first the ICRC-10 supported standards and the ICRC-1 supported standards to figure out what the token supports. Is it ICRC-2 or is it ICRC-80? There's not any 80 canisters yet that I know of, so this will use this to add it. It pulls in the fee, the symbol, the decimal, total supply, and all of that from the metadata that comes out. Check allowance for subscription. This will go and check that items. First of all, it's going to make sure that the number of requests, you've sent 10 million cycles. It'll then check the subscription to see if it has enough allowance and balance to process the next payment. So you'll get an error back if there's not enough allowance or balance, and your service can respond to it. But then you want to send an email to the user if you have their email or their open chat or whatever and say, hey, just heads up, your subscription's about to run out and you don't have enough in account X to process your subscription. Here's a subscribe function. So what happens with subscribe, we check for the dedupe and then we parse them all and then we go through them again. And we're going to check for an existing subscription that matches certain items. If we find one, we can say, hey, this is active, you can't subscribe, otherwise we keep going. We get our token info out of our library. This is where we ran into the problem where we didn't want to call into unknown canisters. So for now, oh, this checks our interval first and end date. If we're past our end date, we don't want to subscribe to something that's past the end date. Then we go to the token info. So for now, if we don't have it in our map, we're continuing, and in the future, hopefully we can use this code, but we're not going to be able to use that code until we get guaranteed timeouts in the new scalable messaging model. So that'll be coming in the future. It's one thing that we'll probably have to upgrade. So the max allowance is calculated by looking at if there's a fee or not, or if there's an end date. If there's not an end date, then it basically just approves a massive amount, which I think is half of the total supply. Now, that's scary to approve. If you have a million ICP in here, do you really want to approve 2 million ICP to be spent out of your account? Well, because it's a smart contract and it's submitted to the NNS, it should not be able to be violated. And once this is sort of burned in and approved and audited and everybody's comfortable with it, then you should feel okay using it for subscriptions and know that it's not going to take more than the smart contract says it will take. We check the allowance before we create the subscription to make sure that you've done an allowance. Then we create the subscription and put it into our database, and we log into the blockchain. We don't charge it right now. Basically what we do is we just add it into our timer tool for the next round. So as soon as the next round comes, we're going to call the subscription payment immediately. This is based off of the next payment and next payment amount. These values get set in the parse function, so they should almost always be set. So we don't expect to hit this. We're just unwrapping them here and then setting up the subscription. And that's that. We clean up our recents, so our dedupe works. You can cancel a subscription. Now, what has to happen here, we have to go get the subscription. We have to validate that it's cancelable. We don't set it straight to cancel. We call will cancel subscription. So what that does is it lets the next timer run, but then sort of degrades the thing gracefully. This way, you can distinguish between a subscription that's been canceled but you've paid already for the interval versus one that's finally canceled. So you'll go from active to will cancel. So say the second day of the month you decide you don't want Netflix anymore, they've already charged you for the month. You'll have a different status of will cancel for the last 28 days, but the service can stay on and distinguish between will cancel and canceled. Pausing subscription is a bit of a switch. If the canister pauses a subscription because your payment fails 10 times, I think, then either the user or the service can turn it back on. But if the service pauses it, the service has to reactivate it. If the user pauses it, the user has to reactivate it. And it's just nice to pause it versus delete it, cancel it, because we know that canceled is like a final thing and that you're going to have to create a whole new transaction. So you'll see that if it's paused or active, we do something, but any other is an invalid status for pausing. This is a helper function to create our product map and our index. We have helper functions to file the subscription in all of our indexes. Here's where we set up the will cancel. This pauses a subscription. Activate a subscription. This is our max allowance calculation. So if you have an end date, it tries to calculate exactly what your allowance should be. This calculates the total payments between now and then. This converts our intervals to nanoseconds so that we can, you can create whatever kind of subscription you'd like. This produces a transaction memo that goes into your payments, I believe, and this should be a common item. So once you have somebody who processes a payment for that subscription ID, if you were looking at a block index, you'd be able to search the memo for the same memo for all the payments and all the fee payments on that particular subscription. Here's our check allowance, check balance, file the notification. Here is a function where we handle the subscription payment errors. If if you get 10 retries, we stop processing. There's a notification in this library to our upper library. We haven't integrated ICRC-72 into this yet, but eventually that'll be nice to admit to someone and say, hey, your subscription's been paused because ran out of payments. We're not just going to cancel you, we'll pause you. We try, if our payment fails, we try it in an hour. So over 10 hours, we're going to try 10 times. Maybe that's not the best pattern to use. Maybe it should be more progressive. But the thing I'm most concerned about here is when a ledger's down for some reason. Hopefully over 10 hours, it frees up. All right, now this is the function subscription payments that actually processes your payments. This gets triggered by the timer when it's time for your subscription to be processed. So every month, basically, if it's a monthly subscription, every month it's going to get triggered. First, we get the subscription, make sure the status is still active. If it's will cancel, we cancel it. Then we calculate the next payment date, the next payment amount, and we get the proper token. If there's an exchange rate, we process it. I would not create a subscription with an exchange rate just yet. This sets up the fee. Then we do the transfer and record the payment. We then try to pay the fee. If something happens and the fee fails, then it's no big deal. Should work most of the time. We don't want subscriptions to fail because the fee didn't work for some reason. A lot of helper functions here for filtering. These search through the different indexes and build the payment and service queries. This gets our different service notifications for the caller. And we have our listeners, so you can listen to, if you're using this component to build your own subscription service, you can listen for new subscriptions, cancel subscriptions, new payments, active subscriptions, pause subscriptions. You can register the listeners. Very much like our ICRC ones. Here's the cycle share code. That's the component. Now, we're going to switch over to our ICDevs website. If you remember before, we added this React Motoko, and here is where we added our app.tsx. And this is the React app where we added the ability to mint ICDV using our ICDV token. What we're going to do now is we're going to add a section to that interface to see if the user who's logged in has any subscriptions to ICDevs. And if they do, we're going to show an interface to allow them to cancel those subscriptions. It'll list out their payments. So if they want to ask us for a tax letter, they can do that as well. And then it'll also allow them to subscribe in any of the particular tokens that are currently supported. Okay, so I've already made the changes and I've pulled these over. So I want to make sure that I have the right declarations. When you build this, you do dfx build check, that's going to build everything. We're going to do dfx generate, which should produce our types in our declarations folder. If you'll remember, we had to pull those in and add something. So I'm just going to grab those. Okay, so now we've got our declarations in there. We're going to copy those and come back over to our website. We'll paste those into this under declarations. We'll create one called subs. And we will, if there's anything in there, we delete it. Otherwise, it'll create copies. And then we paste these in. And we can look in here. The one thing that you have to do is in this file, you have to export the service. We can look back over here, and if you want to see specifically what was done, you can look at the pull request that was generated on this project. Before we get too far along, let me actually show you what this looks like. So if we go to our donations page, this is our local host here. We haven't pushed this live yet. You'll see we have a login with plug here. And now there's some information on minting ICDV as well as stuff. So when I log in with plug, it's going to do what it used to show me, which is that I have this much ICDV and I have this much ICP. Click there to mint, same process we've done before. Now I'll see this, it'll tell me I can subscribe, and I can select any of these tokens, and then I can click here to donate. So let's do that real quick. I'll select ICP, click here to donate. It'll say enter the amount of ICP. Let's do 0.01 ICP per month. And now it's going to approve those 30 years worth of payments. And I got to approve that. I now have a subscription of 0. This is my subscription, or this is my subscription, and these are my payments. And I can see that I've made 2 payments, right? So I don't know if we can actually go and look at these. So if you log in here, you can see that I did this approve for 3.6 ICP, that the first payment was made in two tranches, this going to the ICDevs account. I can go here and I can cancel this subscription. But if I don't cancel it, it's going to run again in a month and take another 0.01 ICP out of my account. But I'm just going to sort of go through it here. You need to import your services. So you get these 2 import lines to import that subservice, and we're going to pull in a couple types: sub status, which is the status of our subscriptions, our token info type, payment record type, and subscription type. Those are the things we're going to be showing. And then we need our subservice to be able to call the functions. You need to add in these lines here to get your subscriptions list, your payments list, and your tokens list. And then we add the actor, so the subs actor. Now, there was a weird error that I fixed in the last version. The plug was popping up in a window. I think they made a change, and all of a sudden, Connect was always showing the window. So I've made a couple edits here that you can go look and see what they were to make it a little less spazzy. Now you actually have to go click the button to initialize the process every time to log in with plug. And it's not as spammy. So as soon as you open ICDevs.org, it doesn't yell at you and say log into plug. You have to specifically click log in. When everything happens, we should see this message that everything's loaded. This is the actor update. So whenever our actors change, we're going to recall fetch balances and fetch subs. So this should get us all of our fetch balances is going to go get us all of our ICDev stuff, and fetch subs is going to go get us all of our subscription stuff. So once we're connected, once it is connected, changes, we'll fetch our principal and set up our actors. This is mostly the same. Here's our fetch subs. We just call get user subscriptions, get user payments, and get token info, and then set those up. When we set up our actors, we're setting up our sub actor pointing to the subs canister ID, which you have to add to the env file here. Canister ID subs. This is the NNS utility subscription canister. Then we scroll down and we have this is interesting. This is a string to number hash function. I needed a hash for my products. So each subscription to a different token is a different product. So what this does is it takes the principal and creates a hash for it. So each token canister is different. Now here's handle subscribe. You have to select a token. Then you go get that token symbol and the amount to mint. And so we give you these messages that are telling you what's going to happen. What we do here is if you've selected a token that's not already approved for plug, so in this case, when you connect, we connect to ICDV and we connect to ICP, but not like CKETH. So if you select something like CKETH, we have to add that selected token to this and we re-authenticate via plug so that we're approved to send transactions to that canister. Then we create a new actor, an ICRC2 actor. And do the approval first. So first you approve the tokens, and the spender is our subscription canister. Once we have an approval result, we're going to do this. This target account, I want to change this target account. Because right now it's going to just something in my plug, but I want it to go to the ICDV canister itself. There are a set of tests back here on this Pan Industrial deal. This is what we want here. Okay, so the target account is now going to be sent to our ICDV canister. And if it's successful, we go get our balances and our subscriptions again. I really should wait a minute because it takes the next round. So I should be able to. You know what? I'm gonna run them both so that you at least see it. But then I'm also gonna run it again in 6 seconds, and I might set it again in 12 seconds just to make sure that all those payments get processed and updated. It's not going to hurt anything if I do that. Just more queries against my server. For handle unsubscribe, we basically just call the cancel subscription and check the results. We have some helper functions here to get data out of our lists. So to get the token decimals, we got to search the subtokens for where the canister IDs match and then return that. Same for this other stuff. Here's what we do when the token changes. This gives us a status in text format. Now, here's where we have the actual JSX code, and we have our card here to subscribe. Picking a token is pretty easy. This is just a React drop-down list that takes the, on change, it handles the token change. The value is a selected token to string. Sort the items by token symbol and add them as options. And we have our button to handle subscribe. That's basically that. If we have subscriptions, then we loop through them and we just create a list item for every subscription showing you what you have. And if you have payments, we do the same here. Now, what we haven't done, which we eventually want to do, is that if you have subscribed via ICP, you should be able to mint that directly to ICDV. So I think what we'll probably do is for these payments, we'll probably add a button there for you to register that. Or we'll wait till we implement ICRC-72. And once we implement ICRC-72 and can be notified that the payment has occurred, we may do it automagically for you. So we'll handle that in a future tutorial. I imagine this one's probably getting pretty long. So that's really it. If we, let's see, I need to do npm run build here. Okay, so you can see my subscription here, my payment, and that looks like it's working. So let's try a different one. Let's try to subscribe with ICDV. And now I have 2 subscriptions, and my payments after 6 seconds, one of them shows up, and then after the other 6 seconds, maybe the other one will show up. Yep, perfect. Okay, great. So this works and it's live, and you can go and donate. And well, you shouldn't donate yet because I still control this canister. And I have added a couple functions to our token. So now that subscription should have sent tokens to my canister at the sub account that we expected. So what I've done is I have added these functions. Obviously, I haven't finished them. This will allow me to This will allow me to withdraw any ICRC1 token that actually accidentally gets sent to my deal, or that goes to all of these subscriptions that are going to come through here. That will all go to this canister. So I can withdraw them with this. And then I added this get balance ICRC1 function that will loop through this and keep track of our canister with our future results. So we can do 8 at a time here. Okay, so this function will loop through all of the possible tokens on our canister and see if we have a balance at our designated sub account. Okay, so now we're deployed and we want to call this function now. This might take a while to run because it's got to check a bunch of different items, but hopefully we'll see at least the balance of the new subscription, the ICDV subscription that we submitted. Here we go. This many from this principal and this many from this principal. So now I should be able to send those somewhere else if I want to using the other function. Now, we've covered a ton. It's probably best if you really want to understand this to go look at the code, which I'll push all up to GitHub. The next thing that we have to do is the sort of really crazy one, right? And I hesitate to do this, but I'm going to. Right now, I'm going to go find the NNS root. So this is the NNS root. All right, we've got a bunch of cycles. We've got our controller. We have 2 controllers. And Laura's going to be mad with me. Sorry, Laura. We're going to do it. You're trying to remove your selfless control of the canister. This made the canister unupgradable. Yeah, man, let's do it. Okay. So we're dead in the water now, and we're going to have to go to the NNS to upgrade anything. So now, if you want to subscribe, provided there's not an egregious bug in the contract, you should be good to subscribe. Oh, look, I can't query it anymore. I probably should have added at least a status function so I could see how many cycles and stuff like that were on it. But we'll have to add that in the upgrade. Until then, I'm going to end that, and we will add some other cool features to our ICRC fungible tokens in the future. But for now, hopefully, if you want to build a subscription service, you have a fairly reliable and predictable and safe and secure subscription canister that inherits the security of the ICP network. And I'll talk to you again soon.